So the correct IUPAC name for the following compound is, so what we see here is we have a molecule that contains two functional groups. We see that we have an alkene and we have a ketone. So whenever you're naming a molecule that has more than one functional group, the first thing you need to do is decide which functional group takes priority. So the priority of functional groups, so priority of functional groups, you can find this in your textbook as table 16.1. And so if you take a look at that table, you will find out that the ketone is the higher priority functional group in this molecule. And so that means that it is going to be named as a ketone, so it's going to end in -one, as we see in A and D. And that also means that we're going to number the chain so that the ketone is part of the parent chain and that it has the lowest possible number. So I'm going to start numbering from this side. So I see 1, 2, 3, 4, 5, 6, 7, and 8. So I see that my parent chain definitely has a 3 ketone. It's 8 carbon atoms, so it's an oct. And actually I need to express where this ene is as well. So I'm going to put the first number of the alkene to show where that is. So it's going to be an oct 5 ene. And then a 3-one. Okay, so we have that. We also have on carbon 5 a methyl group. So we also have 5-methyl. So we have a 5-methyl oct, 5-ene, 3-one, and that's what we see in A and D. And the difference between these is the stereochemistry. So we need to be able to look at that alkene and decide whether it is E or Z. So what you need to do on each carbon atom of the alkene is you need to decide the priority functional group. So on carbon 6, we can see a bond to carbon, and what is implied is a bond to hydrogen. So that means that this top group here is the highest priority on that carbon atom. And then if we look at the next carbon atom, we see a bond to carbon and a bond to carbon. So that doesn't differentiate our priority. So then we would say, well, what are each of those carbon atoms bound to? So this carbon atom 4 has bonds to 1, 2 carbons and 2 hydrogens. And then this carbon atom 5 is a methyl group, so it's only got 1 bond to carbon and 3 bonds to hydrogen. So here we see a point of difference. Right, so we compare the carbon and the carbon, then we go to the next one, we see a carbon and hydrogen. So that means that this bond down here, going in this direction, is the highest priority on that side of the alkene. And so what we're doing is we're going to bisect that alkene. And just as a quick refresher of E and Z, if your two high priority groups are on opposite sides, like we have here in this example, then that is an E alkene. And if they are on the same side, either both facing up as I just drew it, or you could flip it over and have them both facing down, then that would be a Z alkene. But since these are in opposite directions, then this one is E. And so we are looking at the correct answer then being option A.